Hey, period four. Sorry about that mess up. I have no idea what was wrong with my computer. Um, but yeah, Austin stepped in, but it was kind of hard to go through everything because my computer was glitching so bad. So all right, I just want to take you guys through the Gizmo real quick. Um, so this will be really quick. But we had here, like if we look at this circuit, this is a series circuit. So like Austin was saying, the current can only pass one direction. And then a light switch, like a switch there, if you turn off the light bulb, like if you hit the off switch, what happens is it makes a short, so it breaks that light. So I mean it breaks the line, so the light bulb goes out. All right, so that's a series circuit. So down here, when we're looking at series circuits, that means like whenever you have things strung all on the same line. So if it's all on the same line, um, how do you think adding each resistor or light bulb affects the total resistance? So how does each new light bulb affect each other? So you can try this out. So let's open up the Gizmo real quick. Um, I have to pull that up. So let me pull it up real quick. All right. So the circuit building, like the Gizmo is actually pretty fun as you get to like play around with it. Let's throw a battery in there. And the question was, if we have a series circuit, what happens if and let's put some light bulbs in here. What happens if I keep on throwing in light bulbs into the circuit? So let me just make it with one light bulb to start off with. So connecting all these guys. All right. So there's my one light bulb. Okay, so let's throw in another light bulb. So I'm going to take this out. So I'll take out this dude and I'll put in another light bulb. All right, so the kind of hard to see, like maybe we'll throw in another one and you can see on the brightness, like what actually happens here is that the brightness goes down and down. So kind of hard to see, but the so you keep on putting more and more in. Like the light bulb gets dimmer and dimmer. So the you can see now it's like it's really low. So what that means is that if I put this ammeter in here, like as I keep on throwing in light bulbs, the current keeps getting lower and lower. Like so it's at 0.11 there. Let's take a light bulb out and see what happens. Now it's at 0.13. So the more light bulbs you throw in, the more resistance and then the less current. Okay, so that's a series circuit. So let's clear everything. Let's go back to the assignment and let's look now at parallel. So here is, so for C, now we're having a parallel circuit. So for C, note that you build a parallel like this. So we have in a battery, and to build a parallel, we can put the light bulbs in, a row like parallel to each other. So like these are all parallel. And notice now they're not all on the same wire. They're all split, like the wires, like there's multiple wires here. Okay, so that means like unlike the series circuit, if I take one of these light bulbs out, take this guy out, these lights stay on because the current can still go through them. Unlike the series circuit where the light bulbs would just turn off. All right, so you're asked to figure out, well, what happens to the current as you keep adding these light bulbs in parallel? Well, here we're at 1.33. If I put another guy on there, it's at 2. So it went up. Let's throw another guy on there. Now it's at 2.67. So it keeps going up. And it shows this, like what the equation is for this, like as I'm going through. It asks you to come up with a equation, but that would be really hard to come up with. So here's the equation down here for the total resistance. So if the current goes up, that means that the resistance goes down. Less resistance is more current. So here's the equation for resistance. And I'm going to come down here and I'm going to make I'm going to use this equation in order to find the total resistance, or we call that R equivalent. All right, so the way I do it is I'm going to use my formula. 1 over R, and we'll call that R equivalent, is equal to 1 over R1. And then let's do this one. So there's 220 ohms. So there's 220 ohms, so 1 over 20 plus 1 over 20 plus 1 over 10. Okay, so if I do a little fraction, so if I add all these up, to add these up here, I'm gonna have to do a little fraction work. So 1 over 10, well, that's the same as 2 over 20. So if I add all these up, 1 over 20 plus 1 over 20 plus 2 over 20 is 4 over 20, which is the same thing as 1 over 5. But here we have 1 over R equivalent is equal to 1 over 5. So the last step is I have to take the reciprocal of both. So the R equivalent is equal to 5. All right, and that the unit for that is ohms. So this is a quick video, but hopefully this will help you out with the Gizmo. So do your best, and if you have questions, take a snapshot and you can send it to me.